For decades, artificial intelligence has answered questions. It translated languages, recognized faces, recommended movies, completed sentences. It waited for instructions. Now something is changing. AI is beginning to act. Not just respond, but plan, decide, execute, and adapt toward goals with limited human input. This shift is known as Agentic AI, and it marks a turning point. Traditional AI systems are reactive. You give a prompt. They generate an output. The interaction ends there. Agentic AI operates differently. You give it an objective. It decides how to achieve it. That may sound subtle, but it is profound. Instead of asking, "What is the answer?" we begin asking, "Can you handle this?" Imagine telling an AI, "Research the top 3 suppliers for rare earth metals. Compare pricing trends, prepare a summary report, and email it to me." A conventional model might help with pieces of the task. An agentic system breaks the goal into steps. It searches data sources. It evaluates credibility. It extracts relevant information. It formats results. It drafts communication. It revises if necessary. It loops until the task is complete. It behaves like an agent. In computer science, an agent is something that perceives its environment, makes decisions, and takes actions to achieve objectives. Agentic AI applies this idea to modern machine learning systems. The difference is not intelligence alone. It is autonomy. Autonomy does not mean independence from humans entirely. It means reduced supervision. The system decides intermediate actions without constant prompting. This introduces a new layer of capability. Agentic systems can use tools. They can call external APIs. They can write and execute code. They can schedule tasks. They can monitor results and adjust strategies. Instead of single-turn answers, they engage in multi-step reasoning and execution. In business environments, this changes productivity. AI agents can handle customer inquiries end-to-end. They can manage supply chain adjustments. They can conduct market research continuously. They can automate workflows that once required teams. In research, they can scan scientific literature, propose hypotheses, and design experiments digitally before humans review them. In finance, they can monitor markets and execute strategies dynamically. The promise is efficiency at scale. But the shift from response to action introduces new complexity. When AI answers incorrectly, the damage is usually informational. When AI acts incorrectly, the consequences can be operational. An agent that books the wrong flight is inconvenient. An agent that mismanages financial transactions is costly. An agent controlling infrastructure could be critical. As autonomy increases, oversight becomes harder. Agentic systems often rely on feedback loops. They evaluate outcomes and adjust behavior. This adaptive quality makes them powerful, but also less predictable than static systems. The question is no longer just, is the answer correct? It becomes, was the decision appropriate? And that question requires alignment between machine objectives and human values. Developers attempt to constrain agentic AI with guardrails, rules, permissions, monitoring systems. But the more complex the environment, the harder it becomes to anticipate every possible scenario. There is also a psychological shift happening. Humans are accustomed to tools. Tools extend our capabilities, but they remain inert without us. Agentic AI blurs that line. It feels less like a tool and more like a delegate. We assign tasks. It reports outcomes. Delegation creates distance. Distance reduces direct control. Historically, technological revolutions have moved in stages. Mechanization automated physical labor. Computers automated calculation. The internet automated communication. Agentic AI aims to automate decision chains. That is new territory. The implications extend beyond efficiency. If machines begin to handle complex, goal-oriented processes, human roles evolve. Some tasks disappear. Others shift towards supervision, strategy, and creative direction. There is opportunity here, and disruption. Critics worry about runaway systems, about unintended consequences amplified by autonomy. Supporters argue that properly aligned agents could accelerate discovery, reduce human error, and free people from repetitive cognitive work. Both perspectives recognize the same fact: AI is moving from answering questions to pursuing outcomes. The term agentic captures this transition. It suggests agency, the capacity to act, but agency in machines is not consciousness. It is structured autonomy guided by algorithms, data, and constraints. Still, the experience feels different. When a system plans its own sequence of actions, adapts mid-process, and delivers results without step-by-step guidance, it challenges our understanding of control. We are entering an era where AI does not merely assist, it executes, and execution carries weight. Agentic AI represents a threshold. Not the emergence of independent machine minds, but the expansion of machine responsibility. The critical question is not whether it will develop further. It will. The question is how carefully we design the objectives it pursues. Because when artificial intelligence starts acting on its own, what matters most is not how intelligent it is, but what it is trying to achieve. If you enjoy clear, documentary-style explorations of the technologies shaping our future, subscribe to Talking Tech for more deep dives into AI, automation, and the forces redefining human capability.